Welcome! In this lesson, we will use the two-bar magnet simulation to answer conceptual questions about magnetic fields. Watch the magnets, the arrows, the field lines, and the compass as four parts of one story. Start with the controls. The menu changes the magnet arrangement. The checkboxes show or hide each magnet, the compass, and the field lines. The sliders rotate the magnets, and reset gives us a clean starting point. For unlike poles facing, notice the space between the magnets. The arrows point smoothly across the gap, and the field line pattern forms a bridge. This is why unlike poles are often drawn as connected field patterns. Now compare like poles facing. In the middle, the arrows no longer join smoothly. They turn away from the center. That visual change helps explain why like poles push apart instead of pulling together. First, read the red vectors. Each arrow gives a local direction at one point, and a longer arrow means a stronger field. Vectors are best for asking, what is the field doing right here? Now turn the field lines back on. Field lines show the overall shape, so students can see the path a compass needle would follow through the field. With one magnet hidden, the pattern becomes simpler. This is the field around one bar magnet. When the second magnet returns, every arrow is the combined effect of both magnets. The compass is our probe. As it moves, the needle turns to match the nearby field direction. It lets students test the invisible field one position at a time. Move the compass closer to a pole. The field reading becomes larger, and the needle changes direction more quickly. Close to the magnet, the field is stronger and less uniform. Notice how the numbers change as the compass moves. That is measurement, not decoration. A useful check is this. The compass needle should be tangent to a nearby field line and point in the same direction as the local vector. When all three agree, the picture is consistent. Now we are ready to remove the compass and watch the field pattern itself. Now rotate one magnet. This is the key experiment. Do not memorize the picture. Watch how the entire field reorganizes as the pole direction changes. Focus on the space between the magnets. Ask students which arrows keep a similar direction, which arrows swing around, and which region changes the most. This pause is useful. Students can sketch the before and after arrows in the center gap. Below the simulation, the inquiry sequence gives a strong classroom routine. Predict the pattern, turn on field lines, switch from unlike to like poles, test with the compass, then explain the change in words. Use the questions on the page as a checklist for the explanation, not just as decoration below the applet. Use the Explore More links for extension. Students can compare this model with other bar magnet simulations, including single magnet fields, earth field ideas, and three-dimensional field line views. These links are good for follow-up practice after the video. Choose one and compare the field pattern. If this helped you understand magnetic fields, like the video and leave a comment with your question. Tell me which representation helped most, vectors, field lines, or the compass. Keep exploring the simulation yourself. Predict first, test with the model, and then explain the field pattern in your own words.